So in this video we will be discussing about three-level abstraction of DBMS. Three-level abstraction of DBMS, and I have PPT in front of me, and with help of that PPT I am going to explain concept in very simpler manner. So first thing is, a database should be organized in layers so that user don't need to know storage details, storage changes don't break application, and different users see different views. So a database should be organized in layer so that user don't need to see storage details and a storage changes does not break application, and different users see different views. Different users see different views. Now, this is called AMSI, Spark 3-level architecture. So the core idea is divided in core idea. So the core idea is described as a database is divided in 3 levels: external level, internal level, and conceptual level. And each three respectively are what users see and what database logically contains, and how data is physically stored. Right. Conceptual level, how database logically contains, what database logically contains, and how database physically store data. This is at internal level, right? Now, real life analogy is, when you open Google Drive, you see file folders, not hard disks, right? Not binary storage, not indexing structures. The system hides complexity from you. This is what DBMS does. Now, external level, this is highest level. Each user, PPT says, each user group sees only part of database that they need. Right. Now, for example, calls database. Suppose my database contains roll number, name, marks, salary, and attendance. Right. Now, a student should see name, marks, name, marks, and attendance, but not faculty salary. Right. Accountant should see salary, but not student marks. Right. So principal may see everything, right? So DBMS creates different views. Now, external views, user views, external schemas. These are called external schemas, user views. Now, there can be many external schemas because many user group exist, right? External level focus on what does this user need to see, not how data is stored. Conceptual level, this is middle level, and PPT says it describes the structure of whole database. So this level described, right? Conceptual level says it describes a structure of database. So conceptual level says describes tables, attributes and relationships and constraints, not physical storage. For example, conceptual schema may define student, right? Student, student ID, name, department, and course ID, title, and enroll, student ID, and course ID. Right. So relationships like one student can enroll in many courses. Right. This is what it is telling. And global view of database from organization's logical design. Entire organization's logical design you can view using global view of database. Now, logically database structure is one, and it does not care about disk blocks, indexing method or storage location. Now, internal level, this is lowest level and it is closest to hardware and storage. So this is closest to hardware and storage, right? So this level explain, this describes physical storage structure, describes physical storage structure, and this level explains where data is stored, how records are stored, indexing, hashing, file organization and compression, right? For example, internal schema may specify a store, a student table, a store, right? Store a student table in the tree index. Store a student table in B plus 3 index, the hashing on a student ID, store records in records in 8 KB pages, right? For example, a student table stored in B plus 3 index, and the hashing on a student ID, a store records in 8 KB pages. Hashing on student ID, a store records in 8 KB pages. 8 KB pages. Right. Now next thing is, there is only one internal schema because physical storage organization is one, and data independence means changes at one level should not affect other level, right? Now mapping is mapping transforms request results between level. Now suppose user asks in SQL select name from a student, DBMS must understand user view, translate to conceptual schema, translate to physical storage operation. This translation is called mapping. Now there are two types of mapping. External to conceptual mapping, it connects main logical database. For example, a student view, name and marks, conceptual schema, student ID, name, marks, salary, attendance, right? Mapping hides unnecessary fields. Now second mapping is conceptual internal mapping. It connects logical database and physical storage. Example, conceptual student table exists, internal stored using B plus 3. Data independence, this is extremely important. There are two types, physical data independence, internal schema can change without changing conceptual schema, and you can change a storage detail without affecting users or programs. Suppose database changes from linked list storage to B plus 3 indexing. Applications still work because users don't know storage details. This is physical data independence. Changes in index file organization, a storage structure does not affect table applications user, and in logical data independence, conceptual schema can change without affecting external schemas. For example, logical structure changes but user view remains same. Suppose table changes from a student name marks to a student name marks email. A student application still works because external view may still show only name and marks. Right. This was all for this video. Now we will discuss next thing in next video.